This video file is recorded in Sabancı University during the recitations for the CS201 Introduction to Computing course, as it was given in the fall 2016 semester.
Good morning. This is the 8th week of CS201 Introduction to Computing. I know you are tired, you had your exam. How it was, by the way? Good, bad, average? Average. It's not hard, it wasn't bad. What about you? How much do you expect? 80 something. Usually students expect 50, 60, 70, so 80 would be quite good. Okay, don't worry about the midterm, it's not the end of the world if you did bad. But you didn't do bad, I suppose. Getting 60 or so, it's not a bad grade, because you know are not bad points, because the grade is going to be averaged. Some weighted stuff is going to be applied, okay? So most of you guys are not going to get like 80, 90, 100, of course. We're going to get a bit more relaxed this week. We're going to do some repetition. Of course, we're going to learn new stuff, but not too much, as we did previous weeks. We are going to start with the robot class again. We're going to do the same examples, because probably your 5th homework will be about robots. You are going still to program games. Let's imagine 8th week of CS201, and this is your 2nd month you're doing programming, and you're programming games, okay? And the 5th homework, or the 2nd homework about robots, it's going to be a bit harder, okay? That's why I want to refresh your memory. You can download today's samples, by the way, today's codes. And we will start with the robot class. Okay. Probably we are going to show some examples from the hardest one from the exam, if we have time. And again, I'm going to give you some clues how to do your 4th homework, because I saw most of you didn't do it. And tomorrow is the deadline. I think you can do it for a day and a half or so. I'm going to give you some clues how to do it, and you're going to program it, of course. Let's start with the robot class. Again, very briefly, just to remind you. You know, this is when we are dealing with the robot class is not a console application, it's Windows application. We are going to see how we are going to deal it. In order to use it, because since it is a library, you are going to include robots.h. You are going to include the header with this sentence here, with this line here. If you want to define a new robot, this is the constructor. Again, if you remember, this is the environment of the robot. Let me find it. We don't have it. Okay, so they are vertical. I can find it here. Let me show you a demo. So this is the environment. X-axis, Y-axis. This is when we start numbering from 0. So this is coordinate 0, 1, 2, 3, and so on. 0, 1, 2, 3 for the y-axis, and so on. We have a robot. This is the robot. We give coordinates to the robot, and it's doing some stuff, okay? But we are going to do this time, we are going to program it from scratch, everything. In order to define a new robot, you give the coordinates. This is one way how to use the constructor. So this is 0, 0. Another way is giving coordinates x, y, and the direction it faces. We will see it in a while. And we are going to see some functions also. But before dealing with those functions, just let's start a new Windows application. Some of you guys forgot how to start it. So it's not a console application, it's a project, Windows 32 project. You can change your name. This is Windows application. You click on OK, go to next. It should be an empty one. You should uncheck this one, although if it's checked, it's not a mistake. So it's not a console, it is a Windows application. Just click finish, this is it. Now, there's something else that you should do. You should set the character to here. So you go to configuration properties, character set, you set it to not set, and this is it. Now just let me copy paste the codes for today. Let me copy paste everything here. I'm copying this stuff and pasting it here. So in order to use the robot class, you should add 4 items, namely those ones: mini, FW, CPP, and the header. The robots, the header, and the corresponding CPP should be added. Usually it's a polite way to put headers in this section here, and source files are here. So again, this is the robot class, this is the header, and on the robot CPP you have defined what the robot class is doing. So let's see what we are dealing here very briefly. I'm repeating, probably your 5th homework will be about the robot class, and we will do some examples. We'll deal with some examples next week also. So this is the constructor. Always when you declare a variable of type robot, you call this function. It takes 4 parameters, but you can deal it with 2. You can call it with 3, and so on. Okay. So the first one is the x coordinate. The second one is the y coordinate at that grid. Direction by default is east. If you don't set the direction, it's going to be east. If you set it, it's going to be the direction you give. So this is given with this code here. And things, maybe we will deal with that next week. Now you put some things and take some things from boxes. Another important thing is the move function. You see by default the distance that you are moving is 1. So if you just call move without parameter, it's going to move only for 1 box towards the direction it's facing. If you give an integer value, let's say 5, 6, 8, and so on, it moves to other directions. It moves for that certain number of boxes. Again, direction, if it's turned like this, this is east. This is south, this is west, this is north. Okay, by default it's east. We are going to see block probably next week. Turn right. It just turns right respective to the current position the robot is facing. Pick a thing, put a thing you take, and put things in the boxes. Set the color if you want to change the color of the robot. Facing east, those are functions that are return Boolean values. If you are facing east, that you are going to return true. Otherwise, everything is false. This is it. Private data are, of course, the x position, the y position, the color of the robot, directions, and so on. Okay, now we are going to write a piece of code, and we are going to do it together. Just add simple robot demo here. So add simple robot demo. And let me show you what you should get. Again, those are the same examples. You should give coordinates x or y, and the robot is going to move towards the coordinate which is closer to it. For instance, if I'm giving, let's say, 9 and 4, x is 9 and coordinate and y is 4, then I'm going to move towards the x-axis, since x was closer. Also, I forget to tell you something important. You are not going to use cin and cout for printing data. Namely, we are going to use those functions called show message and get input. So if you want to show a message, you just call the function show message and you put the message as a string. Okay. If you want to print something or show a message which is of integer type, you call this the other function. Okay. They have the same name, but they take different parameters. The same applies if you want to print something. If you want to get something, get an input, you're not going to use cin. So you're going to use this one, get input, if you want to take a string input. Okay, this is the prompt. Prompt taking, okay, give x coordinate. This is the prompt, which displays you the message you want to tell to the user. And the input is here. Okay. If you want to get an input as an integer, again, the name of the function is the same. The prompt might be the same. For instance, you might say give x coordinate, and here you will have your input, which is of integer type. So if you go to the previous example here, so let me run it again. Please enter x coordinate. We are using here get input, this one here. So the prompt here is please enter the x coordinate. And now we're expecting an integer value. And the integer value is going to be, let's say, 9 for the x coordinate. Okay? And I press OK. Please enter the y coordinate. This is the prompt. This is the string we're displaying. Let's say I'm giving 7 as the coordinate. And it finished here. So I gave 9, 7. It started from here. Its x coordinate x was 9, I think. Let me check it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. And its y was 7. So 0, 1, 2, 3, 4, 5, 6, 7. 9, 7. Which one is closer? This one is closer, since this is 7 units. And y is 9 units. That's why we moved the robot towards the x-axis. Okay. Sometimes you read, just me show it again to you. Sometimes you read, this is just displaying the message. Here basically we are using show message, string message, this one. We are using this function in order to display this message here. Okay, now we are using get input. No, I don't. Okay, let's run it from scratch. Now we are using this one, get input, and we're expecting integer, this function. Get input, the string is displayed, and we are expecting integer, this one, this function. So, okay, we are giving, let's say, 15. Then we're expecting 30, y position, let's say this is 13. Now we're expecting a string, okay? And we are using the second get input function that is expecting a string. Let's say we're giving pink as an orange, as of color. And it's moving towards x, it's turning, and that it's moving towards the origin of the coordinate system. This message is displayed by default at each program. You don't have to program it. It's always displayed. Okay, so we included a simple robot demo, and you see the get input function here. Okay. Then we are creating a new robot, which is in the position x coordinate and y coordinate. If x coordinate is smaller or equal to y, then what are we doing? We are turning it right 2 times. Why? Because if x coordinate is smaller, it means that the so let me run it. So let's say the robot is here, okay, and you see that the x coordinate is greater than the y coordinate, meaning that the x axis is closer to the robot. That's why, or let's take this example. So let's say the robot is here. We're giving coordinates of 0, 1, 2, 3 for x, and 0, 1, 2, 3, 4, 5, 6 for y, meaning that y is closer. Okay? That's why we're going to turn it once. We are going to turn it again and move it for x coordinates. Okay. This is done with this piece of code here. We're turning it twice, and we're moving it. Otherwise, if the robot is closer to the, let's say somewhere here, then we just need to turn it once and move it for y coordinates. That's why we're dealing, if this is not the case, we're moving it once and we're turning it once to the right, and we're moving it for y coordinates. So let's run the program. Let's say I'm giving 7 and 3, and this is it. You remember the questions? No, we did it already. You remember the functions. Oh, again, something very important that I want to tell to you. In this case, when we are dealing with robots, when we pass the robot as a parameter, we pass it as a reference because we want to see the changes at the robot. And by reference, I mean we pass the exact robot. We don't make a copy of it, a replica of it. We send the robot that we're dealing with. Because if we don't send the robot, so the same robot, let's say I want to turn this guy twice right, but when I send it as a parameter, a new copy is going to be made. This is another robot, exact copy. And I'm turning this exact copy twice right. It's turned, but when the function finishes, the original robot remains at the same direction. Or if I want to change the color from black, let's say, to green, okay, I'm changing it to the function. And when the function finishes, the original robot is still black. And when the function finishes, the green robot doesn't even exist, okay? That's why we send parameters. So we send this one is going to become green if I want to change the color. When the function is finished, I have it set to green, okay? Now, how can I turn back the robot? Back meaning if it's like this, I want to turn it back. So if I'm like this, I want to turn back. And the robot is using only turn right. You can use this one. Turn right again, turn right, and so on. It can only turn right. This is the member function of the robot. So in order to turn it back, what are we going to do? Come on, I know you know it, all of you.
Turn right, what?
Twice. We're going to turn it right twice. Okay? But you see, robot is taken as a reference. That's why it's a member function. So robot point turn right. This is when I say member function, each robot has this function implemented, turn right. And we are calling that using comma, using full stop. So robot, so all of this stuff that you see here are part of every robot that you create, okay? So turn right again. This is turn back. And what's about turning left?
3 times.
Of course. So robot, turn right, again, robot, turn right, again, robot, turn right. Okay, can we do it in a shorter way?
Yeah.
Yeah, how can you do it?
The turn right into one turn back.
Exactly. So we can, in order to, instead of using turn right twice, we have already turn back function. So we call the turn back function, and this function takes the robot as a parameter, and it's doing exactly the same, and it's turning to the left. Okay, this is it. Let me run the program. So I'm giving 9 and 12. Of course, it's going towards the y. Now, if you want, we can do some. Let's turn back the robot when it goes. So, when it finished here, you saw. No. When it finished here, so I'm giving 9 and 5. You saw, it's like this. Now let me turn it back when it finishes. I want to do only this change. So turn back, robot, when it's finished. How do I, my robot, it's called here. Okay. So I give 9 for X and 5 for Y. It goes in the end, it turns, and it's finished. End of execution. Okay, I don't think we should waste time anymore here. Let's start with the other example. Let's add the robot demo CPP file. You'll see probably the robot stuff is going to get harder and harder, because you are going to move your robot with the arrows, right, left, and so on. And there's other robots that are going to chase it and something like that. Have you played the Pac-Man game? Yes or no?
Yes.
So probably you're going to do some Pac-Man stuff, okay? So Pac-Man, you are going to have maybe I suppose, and something similar. This is a game that your colleagues did like 2 years ago, approximately. So you are trying to pick things, okay? And there are robots, demons we are calling them. They're trying to chase and kill you, okay? But you're trying to pick things and run away from those guys, okay? And of course you're going to use the arrows. And those robots move in random fashion. The demons that are trying to chase you and eat you, okay? We're going to see it probably next week, something similar. If not, we can do something. We can give some extra recitations to see it. Maybe someone of you wants to be a future gamer. But first, we're going to see some random number generations, because those robots, those demons that are chasing you, move in random fashion. You don't know how they move. But you have seen the Pac-Man game. If not, we are going to see it again. Now, so that's why we're doing the robot stuff again, because we want to refresh your memory. So what's a robot demo about? This is what you should do. You get this message. You give coordinates, let's say 5 and 9. Then you give one of those. These are all available colors that the robot can have. Let's say I'm giving blue. I'm writing blue here. And it's moving towards X and then towards the origin. How are we going to do that? Okay, let's start from main. We already have this show message. This program moves blah blah blah. We are entering X, we are entering Y. If X position and Y position, if coordinates are greater than 0, okay, then we should enter the color of the robots, and the color should be one of those. So here we should create a robot. How we are creating robots, let me remind you again. So these are the member functions. You can read what are they doing. I told you about the move, about the turn right, and so on. But if you want to declare a new robot, of course you're going to tell the type initially. So the type is robot, and you're going to give the name. It can be Rob, Bob, Sam, my robot, whatever, and coordinates, okay, accordingly. Of course, don't forget to include robots.h initially. So, robots, and I'm going to declare a new robot, define a new robot. Its positions are X and Y that we just gave, okay? Now I should write a function which is called setRobotColor, and it takes the robot, and you see the robot is passed, so setRobotColor. The robot is passed as a parameter, as a reference parameter, and I'm taking another string which is the robot color. This is the string that we entered here. You remember get input here? So robot color is the input that we gave. I gave blue, if you remember. How are you going to do that? Very easily. So if robot color is equal to, let's say, blue, then the robot has a function which is called setColor, and I'm going to give blue. It's already there. Again, let me write this stuff. I'm going to copy paste it basically again and again and again. Okay, if the robot color is Y, then robot set color white, it's going to be white. If it's pink, then the robot's color is going to be set color pink. What colors do we have else? Orange. So robot set color orange. White. If it's white, robot set color. Did I give white previously? Yes. What else? Why yellow, red? Okay, we can use yellow here. We can use red here. Blue, white, pink, orange, yellow, red. I gave pink twice. Green. 4, 5, 6, 7, 8 colors. I didn't use green, so yet let me use green here. So robot set color green. What I didn't use else? Blue, white, pink, orange, yellow, red, green. Which one? Purple. Yeah. Purple. Okay, so this is it. The color stuff is fixed. After we fix the color stuff, what we should do is to move the robot from its position. So we're going to use another function. First, it should move towards Y axis and then towards the origin. That's why we call the move robot function. It takes a robot as a reference, X position and Y position. So what should we do? First, we want to move it towards Y. But remember, initially it's like this. And we want to move it towards Y. So the first step that we are going to do is, of course, to turn it right and move it. But move it for what? For how many boxes? So robot, turn right. Okay, this is done. And robot, move for how many boxes? Come on, tell me. We have X and Y. We have the coordinates. It's here. We want to move it. So if it's moving downwards, it's moving towards. Which one remains constant and which one is changing? X or Y? So we are moving it for Y boxes. Yes. Okay. If let's say this is the X coordinate. Let's say the X coordinate is 0, 1, 2, 3, 4, 5. And the Y coordinate, let's say it's 10. It's here, for instance. So we move it for how many boxes? For 10. And this is the Y coordinate. Okay. Afterwards, we turn it right again, and we move it for 5. But this is the X coordinate. So first we move it for 10, which is the Y coordinate, and then for 5, which is the X coordinate. Okay. I remember students having difficult time understanding it, to my surprise. So we move it for Y boxes, then robot, turn right, and robot, move it now for X. This is it. Let's run the program. No. Where is, okay, semicolon. We are using here if-else's because when we use if-else, like this, only one of them is going to be executed, and this is what we need because the robot cannot have two colors, only one. If we give something that makes no sense, we are going to use a default color, and I think the default color of the robot is the yellow one. So let's run the program. Okay, I'm giving 5, and I'm giving 9, and I'm giving green as a color. So I'm moving the robot like this, and this is it. Okay. Questions? No questions. If you don't have questions, then let's start with the second example. And that one is draw triangle. So let's start a new project all over again. File, new project. Now it should be an empty project, so go to General, let's be fast. You can change the name if you want. Okay. Let's just copy paste the triangle stuff here. Okay. Now let's edit. We are going to see the usage of the for loop here. And what you should do is the following. Let me tell you, let me execute the code. I'm going to print a triangle which has 5 lines. So this is what I'm printing. Let me enlarge the font. Initially, so yeah, should be okay. This is what I'm doing. Or, if I give 10, this is a triangle that you should print. Okay? We're giving it as an input, and our job is to print the triangle. Afterwards, we're going to print the same triangle, but in reverse order, meaning this guy is going to be printed first, then the other one, and so on. Something like this. Now, I want to learn you how to write codes. Okay? It might seem a bit of difficult and hard to do, but it's not really. Okay? That's why firstly you try to come out with the mathematics, how this triangle can be written. Okay? With the logic behind it. Usually it's kind of a formula. What kind of a formula? Let me help you. Let me draw first the triangle we're talking about. So, let's say this is line 1. We have only one star here. Line 2, we have 3 stars. Okay. This is line 0. Let's start from counting from 0. This is line 1. This is line 2. This is line 3. And this is line 4. In total we have 5 lines since we started counting from 0. This is our triangle. Now, everything else is an empty space. So what we should do, in each line we should count the empty spaces that we are going to write, okay, before writing the star, and afterwards we don't care the empty spaces after the star. Okay, we're going to a new line, again, space, 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 new line, space, space, stars, new line, space, stars, and so on. Okay, we don't care the empty spaces that come on the right of the stars. So this is one empty space. Here we have 2 empty spaces. Here we have 1, 2, 3 empty spaces. here we have 1, 2, 3, 4 empty spaces. Okay? I'm writing them so you can see the empty spaces. Now, how many lines do we have here in terms of stars? We have 5 lines. So lines is equal to 5 because we have 1, 2, 3, 4, 5. We start counting from 0. So this is the level. This is level 0. This is level 1, 2, level 3, level 4. Okay. Now, number of spaces. Let's see. And when I say number of spaces, we're interested only on spaces on the right of the stars, okay? Afterwards, we don't care about that. Since by default, the console is an empty space. It's full of empty spaces. We should just write the characters. And also, we are interested in number of stars. Okay. How many empty spaces do we have here? 1, 2, 3, 4. Okay. How many stars? 1. How many empty spaces do we have here? 1, 2, 3. How many stars? We have 3. 1, 2, 3. On level 2, how many spaces do we have? We have 2. And stars 1, 2, 3, 4, 5. Okay. Level 3. 1 empty space. Level 4, we have 0 empty spaces. Here we have 7 empty spaces. Here we have stars and 9 stars. So 1, 2, 3, 4, 5, 6, 7, 8, 9 stars. Now, can we come out with a logic that is going to link somehow the lines, the level, and number of spaces? That's it. We have 5 lines. We start from 0. So can we somehow link the number of spaces with the lines and with the level? Let's denote the level as I. What do you think? Can you be a bit more louder? So 4 minus I. Okay, and what's 4? Why do we have 4? What if the number of lines were 7? Lines minus? Minus I. Very nice. So number of spaces is equal to lines minus 1 minus I, where I is the level. Okay, so let's see whether the formula works. Number of spaces is lines is 5. When I is 0, we have 5 minus 1 minus 0. It's 4. Okay. When I is 1, we have 5. 5 minus 1, this one here, minus I, it's 3. Okay. So this is the formula. Is this clear for everyone? If it's not, let's write. So for level 0, we have 0 lines is 5. Number of lines is always 5, in our case here. Minus 1, minus 0. And this is 4. That's why we have 4 empty spaces. Now let's say for level 1, it's lines 5 minus 1, level 1. Minus 1. 5 minus 1 minus 1, it's 3. 5 minus 1 minus 2. For level 2, this is 2. Okay? So for number of spaces, we have the formula. What about the number of stars? You see, we start with 1, then 3, 5, 7, 9. It should be straightforward, in fact. What do you think? Come on. 2i plus 1. So number of stars is equal to 2 multiplied by I plus 1. This is going to be the formula. If this is clear, you won't have any problem with the program. For each line, this is true. So basically, we are going to make a new loop. And that loop is going to iterate how many times? 5 times, or lines number of times. Okay, if lines is 10, we are going to have 10 lines. Okay, and in each line, initially, the level is going to be 0. And we print the empty spaces, then we print the star. We go to the next level. We print the empty spaces, then we print the stars. Empty spaces, the stars, and so on, up until we reach the number of lines that we have given. So this is the function we just saw. I mean the function, this is the function which, and we saw its output. So we start from I and we iterate lines number of times, okay? We start from 0. If number of lines is 5, we go up to the 4th line because we start from 0. Then we calculate the number of spaces because what we want to print initially is the spaces. And so this is the formula, lines minus I minus 1. Okay? And we print, if number of spaces is 4, let's say initially, we print those with a for loop. We start from 0 till space and we increment it by 1. Okay? We print the spaces. After printing the spaces, we display the stars. And the formula for the number of stars is the following one, 2 multiplied by I plus 1, okay? And we print them with another loop. So we start from 0 up until k is smaller than start, and we print them. Is this clear? Do I have to write it in board or not? So initially, let's say that lines is 5, okay? And we declare those variables. So we want to print the triangle. This is the loop from 0 up to the lines. We are going to print 5 lines, for instance. Okay. Now let's go with the first line. I'm going to play the role of compiler. So initially, let me erase this stuff. We don't need it. I'll take like 2 or 3 more minutes to you. So lines, let's say we have 5 lines. 1, 2, 3, 4, 5. Just is the case here. Then I start with this for loop. This command here is executed only once in the beginning. So initially I is 0. It's executed in the beginning. Afterwards I'm asking, is I smaller than lines? Is 0 smaller than 5? Yes, it is. That's why I go inside. I calculate the number of spaces. So space is how much? Lines minus I minus 1. So lines is 5. For the time being, I is 0. Minus 1, it's 4. Okay? Now with this for loop, I start from 0 up until 4. Basically, I print 4 spaces. 0, 1, 2, 3. Okay? So I print those 4 here. 1, 2, 3, 4. With this cout. When this is done, then I calculate the number of stars. It's 2 multiplied by I plus 1. So I have another box here called stars. And for the time being, I is 0, so 2 multiplied by 0 is 0, plus 1 it's 1. I have only 1 star. I start from 0 up until it's smaller than 1. I print it, so I print 1 star, okay? So initially k is 0. I print k is, stars is 1. Is 0 smaller than 1? Yes. I print the star. This is the star that's going to be printed. Okay, then I go here, increment k by 1. So 0, initially it was 0, now it's going to be 1. Is 1 smaller than stars, and stars is 1? Is 1 smaller than 1? No, it's not. That's why I'm finished. I'm printing new line, and line. I'm going to new line, I'm here now. And I'm going here. I'm incrementing I by 1. So it was 0. No, it's not 0, I plus plus. I becomes 1. Is I smaller than lines? Is I smaller than 5? Yes, it is. I go inside. I calculate the new number of spaces that I should display. It's line minus I minus 1. It's 5 minus lines is 5. Minus I, it's 1. Minus 1, so it's 3. And I print those 3 spaces with this loop. I start from 0. Is 0 smaller than 3? Yes. Space is 3. I print an empty space. I increment it, it becomes 1. Is 1 smaller than 3? Yes. I print it again. 2 spaces. Increment it, it becomes 3. Is 3 smaller than, is 2, so it was 1, it becomes 2 when I increment it. Is 2 smaller than 3? Yes. I incremented 3 empty spaces. These are the empty spaces I've printed. Then I increment it by 1, it's 3. It now becomes 3. Is 3 smaller than 3? No. I'm finished with spaces. I'm displaying stars now. The formula is this one, 2 multiplied by I multiplied by plus 1. So I have 3 stars to print. And I print it as we saw. I print those stars up until the end. Okay? Is this clear? Did you understand it? Yes or no? Raise your hand if you understood it. All of you. If you think I should repeat something, just tell me. You'll have 5 minutes of break because you came late. Let's not stop still. What should you do? We're not finished. So this is our output. Now your job it will be to write a program that is doing the same thing, but it's going to print the triangle in reverse. So not like this, but like this, okay? In reverse. You have 5 minutes. It will be counted towards your activity. We'll be back.